mobile devices, and this makes them interesting to attackers as well, of course. So we have seen a 163% increase of mobile malware just in the last year, which is really a lot. But it's not just about malware, it's also about all these free apps that are out there. Some might wonder, yeah, nice app, it's for free. Why don't the people want to have money if we get these apps? Of course, they're making money out of them, but often from different business cases, like reading our address book, our email addresses from the mobile, or creating marketing profiles, and forward these things to other people that can use it and maybe even sell them. And this was also one reason why we said, okay, we need some kind of guideline how we can test these apps, and this led to the decision to develop this mobile security testing guide. When we decided last year, actually, we did it also because there weren't any guidelines on the market that were really specific for mobile security testing. So in the meanwhile, OWASP also developed some guidelines that are in many parts also similar to ours. But last year there haven't been any specific guidelines. But at the same time, mobile security testing or app testing in our eyes has a specific character, and the normal or the common penetration testing guidelines for web applications weren't really good for mobile app testing. So when we decided to develop these guidelines, we were faced some challenges. At first, it was important for us to identify what are the differences to a common penetration testing. And then we were also faced really flexible preconditions, in my eyes even more flexible than for normal web applications. Like at first, of course, application or app security heavily depends on the device security as well, and we have faced different platforms, different versions of operating systems, if the device is jailbroken or not, if mobile device management is in use, and so on. And we also have even more attack surfaces that for a common web application, because the device can be lost, it can be found, they often use in public networks, and of course also the standard questions, if it's a black box, if it's a white box approach, and so on. What we wanted to do, we wanted to develop a guide that is flexible on the one hand, so for example, that it can be used for different platforms and so on, but also it should give specific hints to the penetration tester how he really could apply that in practice, and also give hints which tools and technologies can be used. Yeah, the result was a general process, which is the core of the testing guideline, but we also showed some supporting tools and practices. Yeah, I will just give you a brief overview of the testing guideline before Johannes will get a bit deeper into the mobile specific parts, which are marked red here, which is intelligence gathering, threat modeling, and vulnerability analysis. At first, the preparation phase, this is basically fixing the contract with the customer, identifying the app, where to get it from, and all these basic things. Intelligence gathering is about getting more information, then the threat modeling, and then identifying and analyzing vulnerabilities before there's also a risk rating and assessment for the vulnerabilities. And one optional part of our mobile security testing guide is the question if there should be countermeasures shown. Jim Manico told us before that this is a really important part for us security and penetration testers, also to help the customers to fix the problems. But this is optional anyway, depending on the situation, depending on the project, and also depending on the requirements of the customer. So Johannes will tell you a little bit more about these three phases now.
Thanks, Florian. Before I start explaining you the specific parts of our mobile testing guide, let me explain you some annotations about them. First of all, we elaborated them in specific for Android and iOS because they are most common on the market. But in general, they are platform independent. So you can apply them also for Windows Phone or BlackBerry. But in this mobile testing guide, we worked out tools and processes in special for Android and iOS. The next annotation for it, we described them using a native iOS CRM app as an example, because the CRM app supports several testable functions, for example, an authentication or different operations on the CRM data, where we can test several security testing methods. Next point why we chosen the CRM app is that it's an open source app, so we were able to test also some static methods, and because it's a native app, so the attack surface is bigger than, for example, than a web app built with HTML5, for example. Just for information, we tested the CRM app with an iPhone 4 with iOS 6 installed on it. The first mobile-specific part I want to show you is the intelligence gathering. The objective of this part is to catch as much as possible information about the app. For that, we divided this part into two separated analyses, one environmental and one architectural analysis. Before I explained it in more detail, those two analyses, let me point out the difference to conventional process. One difference we point out is that most other processes are only focused on the architectural or technical part. That means that they don't consider the background or the company which stands behind the app, or which assets they might to apply on the market with this app. And the next point is that most already existing processes do not consider mobile-specific requirements, as Florian said at the beginning. The two separated analyses in detail. First, the environmental analysis. As I said already, it's focused on the company behind the app and the relating stakeholders in the business to identify the assets and the business cases which the company tries to apply on the market with its app. In this analysis, you can try to analyze the internal processes or structures to identify potential threats or risks. The second analysis in the intelligence gathering is the architectural analysis. There we divided the complete app into three parts. First is the app itself, second the runtime environment, and the third the backend services. While for the app, you can check the network interfaces the app uses or the data which handles in it the app, or you can check for other resources or services the app communicates on the device directly, or you can check for how the session management is realized on the device, or if the app consists jailbreak or routing detection, for example. For the runtime environment, this subpart of the architectural analysis is mainly important if you do not only check the app itself, but also device in combination to the app. So, for example, if you got an app from the customer and a device to check those together, for example. While checking the runtime environment, you can search for mobile device management solutions in use, or if the device is jailbroken or rooted, or which version of the operating system is installed on the device. The last point are the backend services. There you can check which application server the app communicates to, or which databases is in use, or if, for example, a firewall is installed on the backend. The example we prepared for you, the CRM app. For the app, we, for example, could find out that the user session remains until the user logs off manually. That means that also you quit the app and suspend it, the user session still remains. Another point that there weren't no financial transactions are included in the app, or that it runs, for example, on a jailbroken device. So probably there is no jailbreak detection installed inside the app. One last point is that we could figure out some operations we could execute on the CM data on the server side. For example, creating, reading, updating the CM data, the cases, calls, or contacts, for example, which maybe leads some vulnerabilities that a potentially attacker can manipulate those data without authentication, without authenticated him. The runtime environment, as I said already, is not relevant for this example because we could execute those app on our own device, on our testing device, so we don't have to consider, for example, a mobile device management solution which could be installed on the device. For the backend services, for example, we could figure out the version of the CM service on the backend which is running. So maybe we can use those information to identify some vulnerabilities in it. The next sub-part I want to show is the threat modeling. First of all, the threat modeling is for identifying specific threats for an app. For that you can analyze the app specifically, so that means that you take a look at the app and think about what kind of threats might there, or you can use prepared threats. For example, the OWASP provides an OWASP top 10 mobile risk list, where you can see some examples for most common threats for mobile apps. Let me point out that threat modeling should be done already in the development, but in most cases, as you might know, those threat modeling wasn't done in the development because of some reasons. On the right side, you see the process in detail and the several steps in it. First, you have to divide and cluster the app to have smaller pieces of the app, so you can analyze not the complete app, but specific small pieces which are more easily to analyze. The next part is identifying threats for each component. For that you can use, as I already mentioned, already existing list, for example, from the OWASP, or you can take a look at your own at the app and think about possibly threats. For that it's good if you work with the customer or with the development team together for that. Next part is comparing all those identified threats, because we've divided the app in single parts. It is possible that you have threats multiply in your threat modeling. And if you compare those and eliminate duplicated threats, you have only single threats you have to consider in the next steps of the threat modeling. The next step is the weighting of the risk. For that, there are several methods on the market. For example, also from the OWASP risk rating you can use. And afterwards, you risk them, you know which threats you can handle in your penetration test, because most of the time you don't have the time or the budget to test all identified threats. You have to decide which threats you handle. Afterwards, you weight them. You can develop several countermeasures for them. Those countermeasures are important because from those countermeasures, you can build test cases, which we use afterwards in the vulnerability analysis to search for specific vulnerabilities. Before I show you the example for those support, two conventional processes, we figured out that most software testing processes do not include threat modeling. I don't know why they don't include it, because if you include those threat modeling processes to your testing process, you make the complete testing process more traceable and more efficient for all participants, meaning that You can retest the app afterwards and check the identity threads again, or you can tell your customer why you test this thread and not this thread, for example. The example we prepared is from the intelligence gathering. The app-specific part of the process before is that the app provides several operations on the CM data. If you think about that and you can figure out this specific thread, for example, that a potentially attacker can manipulate those CM data without a proper authentication, meaning that he can manipulate the network traffic, for example. One possible countermeasure would be to implement a secure transport layer protection, for example, SSL or TLS. And with this information, what the countermeasure can look like, you can build a test case, for example, to validate the network if it's using SSL or TLS, for example. And with those test cases, this is only one example, you should do this for all the important or the threats which you want to minimize. You should build such test cases, because such test cases lead us to the vulnerability analysis. We can use them to fulfill those vulnerability analyses. To execute those test cases, we figured out 3 different categories of testing methods. For example, static, dynamic, or forensic methods. And before I describe you those more in detail, one difference to conventional processes, for example, the OWASP mobile testing guide, is that most testing guides do not consider all of these 3 categories in detail. Maybe they combine them, or maybe they don't consider one of them. But in our testing guide, we worked out our methods for all of these 3 categories to execute those testing cases. First, the static methods. Those include, for example, reverse engineering methods or source code analysis. The source code analysis, for example, can be executed manually or automatically. For that, there are several tools on the market which you can use. We listed here some tools for Android and iOS, which we are focused on our testing guide. Next methods I want to show you are the dynamic methods. For the dynamic methods, you can, on the one hand, analyzing the network traffic. We divide it in 2 separated parts, one passive and one active part. The passive part is for just monitoring and analyzing the network traffic. That means that you don't try to manipulate it, but only take a look what data is sent over the network. This can be done, for example, at the device. If you record the outgoing network connections, or at a gateway in your network, or if you use an own VPN, for example. The next part are the active network capturing and manipulating. In this part, you try to manipulate the network traffic, to manipulate the app itself. For that, you can do this on your Wi-Fi or also on your cellular network, for example. But if you try to fulfill this, you will be faced some problems. For example, that native apps do not always use device proxy settings, which you have to set to capture those network traffic, or that it uses SSL encrypted connections. But for those problems, there are some workarounds available on the market. For example, special apps which forces the app to use the device proxy settings, or which breaks SSL encrypted connections. But I have to say that those apps mostly only can be run on jailbroken or rooted devices. The next part of the dynamic methods are concerning the runtime analysis and manipulation. First, the runtime analysis is for just getting an overview with which parts the app communicates to. For Android, you can observe the intents, or on iOS, the Objective-C method send calls. And afterwards, you've got those information, you can use it to manipulate the runtime. For that, you can use, for example, those data to call or manipulate specific functions. One example maybe is that you can bypass authentication, so you know which function you have to call to bypass a specific authentication, so you can type it on your console and bypass those authentication challenge. Another example for read and write variable values is that you can bypass jailbreak detection, for example. Jailbreak detection in general are created this way, that a function checks for specific files on the device and then it returns a Boolean value about it, and if you know which Boolean value or where it is returned, you can just overwrite those values, that you can use your app also on a jailbroken device, also if it doesn't developed to be able to be run on a jailbroken device. The last part of the dynamic methods is the file activity analysis. During the file activity analysis, you check the file system changes during you are working with the app. That means that during your type on your mobile phone, you can see directly on your computer which files are used to store specific values, for example. The example we prepared for those dynamic methods are listed here. For example, with the network traffic analysis, we could reveal that the app uses HTTP instead of secure HTTPS connection, for example, and that it sends non-encrypted sensitive user data, for example, the session token or the username or the password, for example. The next part we've tried with our CRM app example is to bypass the user authentication. With the runtime manipulation, as I said already, we were able to bypass those authentication. So we know which methods have to be called to get into the menu, for example, and to bypass the authentication challenge. The last example we prepared is file activity analysis. With that, we could see that each time we log into the app, we see that the iOS key change is red, and therefore it is pretty probably that in the key change user credentials are stored, for example, the username and password. But those have to be verified in the next part of our security testing guide and the forensic methods. During the forensic methods, you can fulfill or execute timeline analysis. That means that you analyze the timestamps that the file system creates. Afterwards, you run the app. With the timeline analysis, you can see which files the app manipulate or modify during its runtime. With these informations, you can connect afterwards to the device and get those files to get or to fulfill deeper analysis of those files. For example, some file types you can consider with those forensic methods are SQLite databases, log files, cookies, screenshots, keyboard cache, shared preferences, and keychain, for example. The CRM app example we prepared, we executed one of the timeline analysis at several points of the app lifecycle, I said. And with the timeline analysis, we were able to identify several files that the app updates during its runtime. For example, some property list files or some databases. With those information, we could analyze those files in detail and check what data is stored in it. For example, the iOS keychain I already mentioned, if we take a deeper look at it, we could see that in the iOS keychains, the user credentials are stored, for example, the username and the password, which is not so good. It would be better if the developer only stores, for example, a session token, or if he doesn't store anything in the key change. Okay, then I will hand over to Florian and he will end our presentation.
Yeah. We're nearly at the end of our presentation. I will just give you a short summary. So actually, afterwards, we're also quite happy with our mobile security testing guide because it makes it easier for us as penetration tester really to consider these mobile characteristics that apps have, and it helps us also to improve the transparency and repeatability, especially when it comes to when we're working together with our customers. Of course, they want to see and they want to be able to track what we are doing. They want also to be able to repeat certain tests, and this is a good guideline for us to handle this. It's also a holistic approach, so it really goes from the beginning to the end of the complete security testing, and it offers us flexibility also to use it for different platforms. And of course, something that we are all interested in, I guess, it ultimately helps to improve the app security. Yeah, that's it from our side. Thank you for your attention, and I think we still have some time left for questions.
Hi, I just have a question about your forensics. You told a lot about the file integrity checks and so on, and I'm just missing something about memory forensic. Did you consider it at all, or just said, okay, for the first step you're ignoring it?
For the first step, I only included the file activities and not the memory, but this is a possible extension for the mobile security testing guide.
Hello. Using the process you've shown, how much time or how much effort do you need for the test of one app, for example, for your CRM app?
Yes. If you execute the complete process, you need a lot of time because the threat modeling and the preparation sub part or process takes a long time to fulfill it. But yes, as Florian said already, you don't have to fulfill each step of the security testing guide. So if you done every step of the testing guide, so you need, I would say, for a single app maybe yes, one day, but it depends on yes, on the app itself, because if you have a complex app, for example, with many functions in it, and yes, it would take a longer time to test it instead of if you only have a small app with only a small amount of functions.
Any more questions? Okay, then let's thank the speakers again.
Thank you.